Okay, this is not the same blockchain presentation that I showed you last summer. For those of you who came to my blockchain, this is an applied presentation. So this is an incremental knowledge. For those of you who are attending the first time, this would still be fine. But before I start the presentation today, I have to give you a few disclaimers, okay? The first disclaimer is, I'm not a fair trade expert, okay? I know fair trade, but there are experts around here. I just know what a fair trade is all about, okay? But I have never implemented or, I definitely believe in fair trade. That is why I'm designing a product. That's what I'm going to show you in a bit. I'm going to be showing you at the end of this presentation a solution, a product that I have conceived that would be able to implement fair trade in blockchain. And this is a product, along with one more product that some of you are aware of, that I'll be launching after, okay? And when I'm talking product and launching and all that stuff, I also want to let you know that this is a very important disclaimer. I don't see you as investors, okay? But probably you could be my collaborators, who knows, okay? So if you're interested, if you think that this is of your interest, feel free to come and talk to me. And you know where to get me, right? Okay, so what I'm going to do today, the presentation is going to have 3 different parts. The first part, very quickly go over blockchain, some basics of that are in the blockchain technology. Just kind of, I can't educate you on blockchain in 1 hour, but I'll try to give you as much insights on blockchain. After that, I will quickly talk about fair trade, and you'll see I really quickly talk about it, okay? Because I don't know much about the fair trade underpinnings. This is something that I'm currently educating myself on. But at least from what I've seen so far and what are the problems in fair trade, and then finally show you a solution, and that is a product called Satya. Satya means truth, okay? So essentially this is a product that I think will help us implement fair trade in blockchain. And it also takes into consideration all the problems, not all, but most of the problems at least that we've seen so far in the current implementations, and makes it much more dynamic. So I'll talk about that product in a bit. How many of you have had any kind of exposure to blockchain? Not Bitcoin, blockchain. What about the MBA class? I'm giving you a shock. Okay. I think it was last summer, right? Okay, so this is a very loaded definition of blockchain. A blockchain essentially is something which is decentralized, okay? The key idea in blockchain is we would not have things in any kind of a central place, okay? And then there is a lot of complexities involved when you decentralize, okay? How do we coordinate with one another? How do we make sure that after we have decentralized, we're still able to secure that data? Yeah. So, and with this kind of a model, now we can do transactions with anything: money, goods, property, work, or even votes. Okay. This is probably what many people are calling the future. This is very secure, at least currently. There are some security holes that have been found out, have caused a few problems recently. But overall, nothing in this world is 100% secure, but overall, this is designed to be a very, very secure system. To be able to kind of give you a quick overview of blockchain, I want to start with the basic peer-to-peer. How many of you have kind of bought and sold things on Craigslist? Did it go well? I hope. Most part, yeah? Okay. What happens is, over here we are talking about companies, yeah? So imagine that these 2 companies have decided that they would do a peer-to-peer transaction. We don't want anybody as intermediaries, Okay, so this is company A with their ledger, okay, and this is company B. Company B is a bit funny, okay, that's why it's tilted, with their ledger, okay, and this is fair trade, so let's talk about coffee. So company A is selling coffee to company B. Now what would happen in this kind of a scenario is, these two companies have to agree to certain terms. They are companies at the end of the day, right? And when A sends the coffee to B, B makes certain entries into their ledger, A makes certain entries into the ledger, a payment is made, the business transaction is completed. But then we have problems in this kind of a transaction. The problem is that somebody in company A was not efficient enough and recorded something incorrectly. Okay, I'm talking about multiple transactions, right? So there are many transactions going on in an organization. You could have someone in company B just tearing off that sheet saying, oh, we never received that payment. So you could have a tampering process. Yeah, somebody could tamper. And sometimes, unintentionally, you could lose records. Yeah. So this is a big problem with a peer-to-peer transaction. So if two individuals on Craigslist, that's fine, right? On Craigslist, you're doing a business transaction, or it's not actually a business transaction, somebody's selling something, you're buying it. But over here, this is a business transaction between organizations. Okay, so this problem, we need to have some kind of a solution. Actually, we do have the solution. Oh no, not actually Bruce Lee, but yes, what happens is you have intermediaries who come into the play. Okay, and when we talk about intermediaries, the intermediaries are a law firm. Okay, so now you have a law firm which actually makes sure that you agree to those terms. Those terms are enforced. In fact, I've just drawn a very simplistic view here. You would have two law firms. How about that? Okay. And then when you have the monetary transaction, you have a bank that comes into play, right? And what has happened over the years is that these overheads have increased the cost of our transaction. When we want to do business, we have to take into consideration the legal costs. When we have to do business, we have to take into consideration the cost that we would incur because of banking, right? And it's been seen that, sometimes people don't do business. Two companies don't do business because it's not worth it, okay? The legal and the banking fees would probably be more than the actual cost of the transaction. So this is where we start thinking of some way where these two companies, A and B, okay, get connected to a global node network. Now we still have those ledgers, mind you, but we know those ledgers are, some kind of problems can happen, you can lose that information, but how about spreading this ledger all over the globe? So everybody has the same copy of the data, right? Now, if everybody has the data, suppose something bad happens at A, you can get that data refreshed from somewhere else as well. Yeah. So this is the core idea of blockchain. This is what, what we want to do is all the nodes have the same data. Okay, all transactions will be stored permanently, so you can't delete anything. And this makes us, achieve what we were not able to achieve in a common peer-to-peer network. Okay, so just to kind of quickly go over what blockchain is. So blockchain is essentially a distributed ledger, and this is a distributed ledger where it keeps recording the transaction one after the other. So it grows also over a period of time. And all the information is stored sequentially, so one after the other, okay, and you cannot alter any information. Now, this is a big deal, but then there is a fear which most people say, you know what, my data is stored in every single computer. Now, this doesn't quite make sense And this picture is just a representation of some people kind of fearing that if I put all my data in somebody else's computer, they'll see all my transactions. But actually, that's not the case in blockchain. Okay, we have a public key, and this was in the time of World War II, where they actually introduced the public encryption module. And this is so interesting that you are able to send in data. And in very simple terms, it's like I give you my email ID, but I don't give you my password, right? You can send me an email, right? All of you can send me a message, but only I can read that message. But this is much more secure than that. This is just in a very simple term. This is how the public-private key is set up. Okay, so what we do is you have a public and a private key which are generated in pairs. Okay, and what we try to do is any kind of transaction, be it a message, be it a money transaction, is hashed with the private key of the person. Okay, so with the private key, when you hash that message or you combine it, hashing is a computer science term, sorry, but when you combine them, okay, you get a digital signature, a big digital signature. And that digital signature would show that this was generated by somebody who has this public ID and who was able to access the private key of this public ID. That is how all those transactions happen, okay? So once you've generated the digital signature, then you actually generate a hash code. And you have a pretty big hash code, which is about 64 characters, which would mean nothing. If you're looking at it, actually, it's just a digital stream. Now, you can always generate that hash, but you cannot recreate the data from the hash. That is how you are able to secure the information. So even if your data resides in the public domain, only you, the person who has access to the private key, is able to decrypt the data, not everyone. But everybody will be able to see the public key. So whatever is the transaction and the public key is visible to everyone. Yeah? Now, just quickly going over how things get linked in a blockchain. Okay, the first, especially in the Bitcoin blockchain, was the first unit or the block was created by Satoshi Nakamoto. Okay, on January 9th, I believe, 2008. If I'm not mistaken, maybe the date could be a bit off. That is called the Merkle root. That was the first block in Bitcoin. Yeah. Similarly, every block gets added. Okay, like the first block, then you add the second block and third block, and so on and so forth. But the addition of this block is essentially the transaction of the data, right? And this addition process is where you are able to link your next block with the previous block, because every block has an address. Yeah. So what we do is, to be able to get the second block, we need to have the hash value of the first block, and so on and so forth. So this is how you keep linking the blocks. Yeah. Now this linkage of the blocks requires us to have some kind of a miner. Now, this is not the physical miner, but in blockchain world, a miner is essentially a validator, a person who, whenever you declare that I have done a transaction, okay, there are some people who will look at your transaction, validate if what you are saying is absolutely correct, and validate your private key, public key combination, and then say, yes, this is fine. They have to solve a mathematical complex puzzle, which is NP complete, so don't worry about it. That's basically, they have to solve something to be able to show that they have done that work. So it's called a proof of work. There are different kinds of algorithms to mine. And once they've validated that, then that particular block is hashed with the chain, essentially. That is how the whole blockchain keeps growing. And it's, of course, broadcasted to the network, so everybody kind of adds this particular block to their data set. Okay. This is how all blockchains in the current times function. This is the idea behind blockchain. Although the addition process of blockchain might have different kinds of approaches, like, Bitcoin has a proof of work, EOS has a delegated proof of stake, where, these are, that's probably another time, some other time I can go over that piece. But just that there is a validator, there is a validation process, and with that validation process, you are able to add a block to the blockchain. Now, I've been saying that no data can be changed, right? So essentially, the setup of the blockchain is done in a way that, it is almost impossible to be able to remove or delete any kind of data or change any data, in fact. So what happens is, suppose you want to kind of, what's happening? Yeah, okay, this is too light. Let's talk about block 2. Suppose I want to make changes to block 2. There is some transaction in block 2. So suppose I sent you money and that money was debited from my account. Yeah. Now I want to play bad and I want to remove that information so that that money is credited back to my account. Okay. I have to go and change the data in block 2, build that connection from block 2 to block 1, and also build the connection from block 3 to block 2. And of course, this blockchain is just not 3 blocks, but maybe another 100 blocks. And do all that before a miner adds a new block. You understand the complexity? It is so huge. So suppose there are 5,000 blocks, and there is block 2,000 that I want to make a change. I have to do 3,000 blocks plus 1 faster than anyone who does 1. Unless and until I have quantum computing or 50% of the network strength, I will not be able to do it. That is why most of the blockchain platforms don't allow a same person to validate multiple times. And if you have 50% of the bandwidth of the computing power in the network, it would just kick you out. So there are different ways to protect that. So essentially, that is how this whole data is protected, cannot be modified, and secured. Just to quickly go over the different types of blockchain. Well, not exactly like this, but there are basically 3 types of blockchain. There's one blockchain which is the public blockchain, like the Bitcoin, the Ethereum, the EOS, where anybody and everybody can join. You have to do a KYC, which is also known as Know Your Customer. They need to know who you are, because otherwise there could be some sanctions and other problems that they could face. But a blockchain network like Monero, which is anonymous network, you can go and join there. You don't have to tell them anything. Okay, so that is mostly the public blockchain environments. Then we have public but permissioned blockchains. So these are kind of, you don't have open access, but I'll give you access if there is some kind of a barrier to entry, but still in the public domain. Yeah. And then you have organizations who set up, or consortiums who would set up their private blockchain, which is only for their organization or organization consortiums. Okay. Just going to show you one more concept of tokenization as to how assets, this is important for us, because when we are talking about asset movement in supply chain, how does blockchain track those assets? So what we do is, again, we come back to coffee. Company A is selling coffee to company B, but we don't know what is the coffee, how much is the coffee, what is the brand of the coffee. So what we do is, we do a process which is a tokenization process, and in this tokenization process, we create a digital token. So the coffee is given a digital identity in the blockchain. Yeah, the digital token can also have a lot of metadata. Okay, The metadata can have provenance, which is basically where the coffee is coming from, all kinds of historical traces. I'll show you an example in a bit. It's not coffee, but something else, but I'll show you how it is set up in the supply chain. And you can also assign a QR code to this coffee. Okay. Now, I don't want to sound crazy, but there are companies which are doing even more than this. And there are companies which are adding Internet of Things, so devices which have IP addresses, which are able to record multiple things. So when the coffee is being transported, there could be an IoT device which could actually record the humidity and upload that humidity data directly into the blockchain. Nobody can do anything there, right? So you could have multiple things built around this, okay, which would give us a lot more information than what we have currently. But this is a very simplistic view of how tokenization works. So essentially, every physical entity can be digitized. This could be property. This could be a house. Yeah. Just talking about houses, I just want to show you a basic traditional contract. How many of you have been involved in buying or selling houses? Good process, right? Very good process. Yeah, so suppose you have a seller Bob and buyer Alice here, okay? Both of them would have to have a broker, generally. Now the brokers are tied to some kind of a trading place, yeah. Now this is essentially securities. Over here, I'm giving you an example with houses, but you could go through a security process also with the same kind of setup. The brokers would go to a central counterparty clearing, okay? The central counterparty clearing, and also go to the custodians of the security. The custodians would revert back to the central counterparty clearing, and then you would have central security depository, which would basically validate everything, and all these complex overheads for no reason, costs that we have to bear for every single transaction, is how most modern day contracts, modern day, I'm saying modern day, yeah? Because I'm going to give you a postmodern view of how things would be or should be in the future. This is a very simple approach of the same thing. Alice and Bob, Alice has a cash ledger, just gives money. Everything is updated in the blockchain from a money perspective. And Bob has an asset ledger, and the asset is transferred to Alice. Where are the intermediaries here? None. Of course, this is simple, but when we talk about how do we implement this in a blockchain, we have something which is called a smart contract. And the smart contract is essentially something which goes from one state to the other if something happens. Yeah. So if this happens, then the smart contract. So it's a trigger-based model. So over here, you have the same transaction, a visual of that. So you have that contract embedded in the blockchain as a code. When you have the transaction, right, then you have accepted that transaction, and you write that accepted transaction into a blockchain, a block rather. The block has to be mined by someone and then eventually added to the blockchain. And this is how this whole thing is implemented. The smart contracts are implemented in blockchain. Okay. Most of you over here have heard me talk about supply chain, the definition of supply chain. So supply chain is the whole network, right from the raw material to the end consumer. Yeah? And what we want to do is to have some kind of a model that we are able to have less and less barrier of entry of people entering into the supply chain. At the same time, have a very fluid transactional model. So if something is done, we are able to handle that, manage that, have oversight. Most of the supply chain literature or research that we do is focused on a relational supply chain. Okay, and that is one research that I'm doing currently, that if we move to a blockchain model, would that relational supply chain be disrupted? So I don't have that answer right now, but that is something that we are looking at. Okay? So, sometimes people say, oh, technology will make us less human. That's not what I believe in. Technology will make us more human and much more smarter. That's how, that's what I'm kind of studying here, so I don't know much about it yet, but when I have some more, maybe in a future presentation, I'll talk about it. So when we talk about supply chain, okay, the current implementations of supply chain have a very siloed approach. So all these organizations, the raw material, the supplier, the manufacturing, distribution, custom, they would have their own software setups. Okay, sometimes they are partnered with one another, but mostly they are very siloed. Okay, there is a huge scope of human errors. So when we have a supply chain, and you're doing some transaction from one company to the other, same example as A and B, and somebody takes off something, somebody doesn't want to show you something, very common, right? So things like, if there is some kind of a problem with of vegetable recall or something, and you need to trace the root, it's not that easy. Even bigger organizations like Walmart, who command so much of power, have to go through a lot of iterations to be able to find out what was the source of the problem. Yeah. So these are not coordinated. There is lack of transparency. But then when we talk about blockchain, it can be easily controlled. Okay. There is of course, we're still humans. As I told you, machines are not taking over. But yes, we'll have less scope of human errors. Usually what we do is we have some kind of a triangulation mechanism when we store data in the blockchain, if it's just pure human. You'll have complete transparency because it's in the blockchain. Yeah, and it's of course coordinated, so you can have the digital asset in one place only. So digital asset cannot be in 3 places at the same time. With that kind of thought process, you will be able to track the digital asset. There is one thing that I have not put in here, and which I feel very strongly, is that blockchain also reduces the barrier to entry. When we talk about organizations doing business in the supply chain, every company has to have, some kind of support, banking, all kinds of things. But in blockchain, what we call is a zero organization. I can call myself as an organization. It really doesn't matter. Yeah, if I'm able to deliver what I have to deliver, that's fine. Yeah. So this is another thing that blockchain facilitates, which the current models don't. Okay. I was telling you about implementations of blockchain, and this company, this Everledger, they have implemented a blockchain for high value assets. Okay, and they are giving a lot of visibility to their high value assets. I'm just going to give you one example from their Diamond, and this is like from their website. Okay, so over here, when you it's called a Diamond time lapse. So actually you can get to see how the Diamond moved that asset, digital asset. This was mined in this country. When you click on the rough image, you will see, what was the first shape of that diamond. When you see, the whole certification process, you can see the whole certification process. You can see who chose that diamond. You can see who architected the diamond. All the details are there. You can have videos and other stuff also that goes along with it. You can see who cut that diamond. Yeah, you can see who crafted that diamond. You can see who groomed that diamond, and you can see where the diamond is being sold right now. Okay, you can get a complete report of a digital asset just because we gave it a digital token and we tracked it throughout. Yeah, in fact, I don't think you'll have anything after this because probably customers won't want to see what they are doing with the diamond, right? So let's stop here. But this is what, when I've been seeing a lot of these kind of digital tracking systems by blockchain lately, This is what has been this has been my motivation for starting to think one step further than what is being done. So these setups that and most of the blockchain setups that I see with any kind of devices, be it fish farming or anything, they mostly are set up for an informational purpose only. Okay, they don't have a dynamic relationship attached to it yet. Okay, and that is why, just quickly go over fair trade, as I gave you my disclaimer that my knowledge in fair trade is very limited. But from what I understand is that when we talk about fair trade, the key idea is that when we buy a product and the price that we pay for the product, and if it's fair trade branded, we know that there is someone who's making that product, gets the right price from the very onset, and if there is some kind of profit, there is a profit sharing which is given back, which actually helps in their social and economic development. Did I say it right? Okay, great. I mean, there are other different pluses and minuses, but coming from Canada, fair trade is a big deal there, and every day morning coffee, we had to have a fair trade coffee. What has been seen is that, as we move up the supply chain, of course the customer is at the very end, the people towards the left, those real farmers, the people who are making the product, become less and less. They don't have that much of power. Once they've given up their asset, nobody cares for them, essentially. Too bad. You sold it to me for 15 cents, I make $3. I'm smart, okay? That kind of an attitude, okay? So how has fair trade been enabled is mostly, there is some kind of certification processes which go to all these farmers and their whole supply chain. They look through their whole process, make sure that this process is compliant, fair, honest. Okay, just some examples, and this is from CBC, Canadian Broadcasting Corporation. Conventional coffee and fair trade coffee, and you can see the share that goes to the farmer increases from 11 to 28%, and not only the farmer, but also the trade costs reduces considerably. The exporter also, the export gains slightly more. The roaster has a reduction in their profit share. The distribution has an increase, and taxes, of course, stay the same. But just to be fair to every single person, irrespective of the power that they command. That is the key idea. And what we do is that these certifying bodies are essentially defining these protocols, going there in different places, looking at how those businesses are done, set up some kind of cooperatives to be able to protect the farmers, so that there is some kind of social and economic development, there is some kind of sustainable development. So, all those things are taken into consideration, and essentially achieve some kind of a fair trade, certify a product as fair trade. But what has been seen, okay, and I have very limited sources for this, but what has been mostly seen is that certification process is the only oversight. Most of the times, when you certify, everything looks good, you certify. But then we don't have 100% guarantee of whatever is promised is actually delivered. So if I promise the farmer, I'll buy things from you at this particular price, but if I make a profit, I'll share the profit with you. We don't know whether that's actually going. Some places, you could still have human errors, genuine errors, and corruption in these countries. So, all kinds of corruption in this also becomes an impediment for fair trade, and it actually does not monitor, and sometimes whether that money reaches the farmer is something they cannot say for sure. The other problem is, and this is something which was found by Bill and Melinda Gates Foundation, is that farmers are not able to sell all their products to fair trade. About 18 to 30%, 35% of the products are what they are able to sell to fair trade. And in fact, people who buy in fair trade also allege that the farmers are selling their better crop to open market and the lower quality to fair trade because now we have locked down a price. I mean, this is the naysayers most of the times, but there are different parties involved here, but the fair trade is a much more complex phenomenon. It's not that simple. There's so many parties involved. There's so many iterations that happen here that, some kind of oversight, some kind of control, some kind of management is required. So for that, I would like to introduce to you my upcoming product, Satya, which is, again, as I mentioned to you, Satya in Sanskrit means the truth. It's a blockchain protocol for fair trade. So it's something which people can use, implement for fair trade. Again, in this model, in this protocol, what I have is a permissioned blockchain. So I have a public permissioned blockchain, to be more specific. So I can't have everybody doing business. We can't do this in a Bitcoin framework. It would not work. But you have to have a permissioned blockchain. And I also am an advisor to a company called Namachain, which is an identity management platform. It's a Canadian company. And what we do is that everybody gets a digital token and we integrate that digital token with multiple identities. So suppose you are interacting with your IoT device, like a camera. Yeah. So the camera is linked to your identity, and anything that you do to the camera is recorded to the blockchain under your identity through a different layered architecture. So that ways you could link your identity to multiple IoT devices, okay, Internet of Things devices, and these IoT devices could execute smart contracts for you. So this is what we intend to do with all digital assets. So now this would make the business much more scalable. And of course, we have something which is called a market oracle. So there are different kinds of triggers, as I mentioned to you. You could have an IoT device which kind of generates that trigger, and you could have the smart contract executing that smart contract. But you could have a human oracle, which means a person kind of validating something, which is generally not what we would like to do. And you could have a market oracle. So you could actually have something connected to the open market. And when things or situations change in the open market, that would serve as a market oracle. So this is market oracle, or even sometimes third-party oracle are used in a lot of places, especially in developing countries. With farming, they have introduced something which is called a micro-insurance. And when farmers kind of want to invoke their insurance because something went bad with the weather and all that stuff, they use the weather oracle. So they actually look at the weather data, and from that weather data, nobody needs to go and validate anything. They automatically, the smart contract executes, and the farmer's claim is given to the farmer. So over here, we could use a market oracle, which would create those triggers. We'll start. The first thing that I would have in this whole model is to give a digital identity, as I mentioned to you. Every individual would have a digital identity. To start with, the digital identity would be powered by biometrics, but then nobody stores these biometrics. The biometrics is in the blockchain in an encrypted format. So, it's not that somebody can steal your biometric, but that is the lock and key mechanism that you would have. Yeah, and then link those digital identities to other digital assets that you might have. And of course, go through a KYC process to be able to make sure that KYC is know your customer, to make sure that you are who you are, kind of thing, to be able to make sure when we are doing transactions, there are certain legal things that we need to comply to. Then the second stage is what I call as the dynamic smart contracts. So as I mentioned to you, based on the market oracles, we would create a dynamic relationship. So suppose there is a consortium of farmers. Over here, let's talk about one farmer. Yeah, you have one farmer, you have somebody who buys from the farmer, and you have a market oracle which would actually give you all kinds of information, and in a bit I'll show you how that is trained. And based on that information, you have the first interaction. Yeah, you set a price. After everything has been done, you have a smart contract predefined, which would automatically execute and give the farmer the fair share. So now you don't have to have any kind of oversight. I'm pre-selling the thing, I'm sorry. I'm too excited about it. So over here, the cocoa farmer and the exporter, what is going to happen is you have a market oracle, and the price is determined, and the profit share is determined also. The final sales, though, the final sales triggers all the back contracts in the value chain. Now, we don't have like a million players here. We'll have probably 4 or 5 different players. But based on how those contracts are coded, and those are coded fairly because you use a market oracle for that, of course, there is a human part too. It's not the machine taking over again. I don't believe in that piece. But the information that we get is going to be a fair information, and all the funds are automatically remitted towards the other side of the supply chain. So the overall model of Satya is, so you have Namachain, which is the identity ecosystem or identity gateway. We have a historical data of the prices with which we do some kind of machine learning. So whenever you do machine learning, what we have to do is, machine learning is software which need not be programmed, but the data is what helps it determine things. When you give it any kind of situation, it will give you an output. But to be able to do that, you need to train it first. So based on historical data, we are able to train that machine. At a certain stage, the machine would have some kind of accuracy with the data. So this is a programming part. Then we bring on the market oracle to this whole picture. The market oracle would give you certain kinds of data sets which we are seeking. Of course, these are reliable government data set, and we probably have triangulation also over there. And based on that, you can generate the smart contracts with their terms. So this machine, of course, there would be templates for the relationship, but the data that goes in is generated by the machine learning. And these smart contracts would then get into the blockchain and essentially the whole value chain, and would do what we want to do based on the relationship, to be able to do all the transactions in this particular setup. So what I feel and what I think is that this is the first blockchain for fair trade. I Googled it, I looked it up, I did all kinds of things to see if blockchain and fair trade. So there is something which is called fair taxi. That is the closest that they've gone in blockchain, okay? But nothing outside of that. So this is going to be the first blockchain solution, fair trade. So, and this is the first presentation of the first solution. So this is history being created here. This would give complete transparency. That is one of the key objectives. The funds would be dispersed automatically, so no more waiting on people and all that stuff. Everything gets triggered, one after the other. Of course, there are certain regulations that we have to comply to, and that is something that I'll have to look at and talk to different kinds of parties. I'm not expert in financial international financial payments, so I need to talk to someone who knows that. More robust than what we have currently, triggered by market events. And this one is something that I really like. This is scalable to any product. Anything that we can trade, we can scale this up to, and we can make it a fair trade. And the last one, self-certifying. So you don't have to go through a certification process to be able to have a product which is fair trade. When you're doing business in this framework, everything is self-certified. Thank you very much, and please support fair trade. Thank you. time for some questions. Yes, Danili.
So when you mentioned the identity that is assigned to the diamonds, I was just wondering if there is application somewhere else to use the same analogy. For example, for medical devices, if you were to produce something that will go into the patient's bowel replacement, the heart, whatnot, I think that would be very beneficial to know where it was produced in the end user location in case something goes wrong to be able to find it.
Absolutely, absolutely. So, see, you thought of a product now. And I think medical devices is definitely going to be one area where blockchain is going to have a huge impact. I have been approached by somebody in medical devices. I can't name him now because I'm on camera, but he was one of our students here and who's very interested in looking at different options. So he said, you know, would you guide me? I said, absolutely, I'll be happy to. I'm yet to meet him, but there is some things, and if you are interested, you know, we can talk about it. Yes?
Now, are there going to be multiple like blockchains, or is this going to be one huge blockchain? Like for each sector of business, like if you're in like air parts, would there be one specific blockchain for that? Or like medical parts, one blockchain for that?
That's a very good question. Actually, this is where, you know, we're going to have some problems in the future because you would have multiple blockchains and these blockchains have not been designed to be interoperable. Okay? And currently there is something which is called a chain off chain, okay, which is trying to kind of pull one blockchain data over to the other. They've not been successful. But yes, this complexity needs to be solved sooner than later. So now when I'm making a protocol, I'm not making a blockchain. I'm going to be getting into a blockchain, you know, whatever big blockchain like Cardano or something, and launch this protocol and in multiple places maybe, okay? But if I started another blockchain, then it would be, it's like many people living in different places, you know, different, and these boxes can't talk. Currently, technology does not let you talk that much. You can't move data from one place to the other. But people are talking about how can I move from Bitcoin to Ethereum, okay? So that discussion is out in the community, but we haven't figured that out. Any more questions? Yes?
One of the big benefits from blockchain technology with Fairshare and with other stuff that you talked about is how it eliminates traditional intermediaries. But judging about like how it needs to be applied and like your product and then the other big blockchain you just mentioned, would that just replace with new intermediaries that we now have to trust? With going back to the
Interesting.
that you were talking about.
So you're talking about this platform being the new intermediary. Is that what you're suggesting?
Yeah, I think, and I might not just understand the whole thing. But.
So see, the benefit of a technical platform being an intermediary as compared to an institution is that, first of all, you can select the technical platform. And most of these technical platforms, the protocols that they have, the way things interact or work in these are defined by the community. Everything is open source here, okay? So you actually are not forced to follow a norm, but you are a part of that norm definition process. But yes, I agree that to be able to run, these platforms need some kind of a transaction fee. But those transaction fees are like a very small fraction of what you see. And also the time factor. So there is more fluidity in the network, as well as the cost gets reduced considerably.
So you mentioned the market oracle that determines what the fair price is supposed to be based on what's going on in the.
So the market oracle is like a reference. Okay, so that is where we go to kind of, and of course it's a triangulated data, so we don't trust one source only. We'll have 2 or 3 different sources. It's like, you know, there is a site which rates all the forecasts, so you give different weights. This forecast is rated A, B, C. So over a period of time, that is what would be developed. So, you know, go to 3 or 4 different sources, which would define prices, and then based on whatever weight they command, we build a composite price.
Okay, okay. So that's defining what the fairness is. Because usually fair trade is a fair trade organization decides what's considered fair. And
That's right,
stamp. So
yeah.
now it's replaced by the market oracle.
Yes,
But
it is
usually
not
not fair.
actually replaced by the fair trade could also be one of the market oracles. I'm not saying that fair trade would be replaced. I'm saying that by doing this, we would be able to code all these things in a digital contract which would execute on its own. See, one of the limitations of the fair trade is that they set a price, right? Now, sometimes, farmers feel that, okay, I can sell in the open market at a higher price. They don't sell most of their products. This is coming in for data. I don't have information to be able to validate that, but this is what I've read, that people have said that this is what happens in many fair trade organizations, that they have a problem of quality. So if we actually are more market driven, but fair to the farmers, best of both worlds. See, that the problem is that if you're market driven, we kind of don't look towards the farmer, but this system will be able to build the farmer into this
Okay.
market-driven model.
Yeah.
Again, I have to go back and validate the models, whether this actually would make sense, but most of the critiques are that when we fix a price, that might be good, that might be bad. But if we have, what I'm recommending here is, if we have a dynamic price,
Yeah.
then maybe everybody would be a winner here. Of course, there is, depends on the type of value addition that you have also. We would have to train the system to be able to understand that, okay, this is the kind of value addition that has been done here, and the price should jump from here to here. And in the open market, if it's sold for $200, doesn't mean that the farmer actually produced something which was $200. There could be somebody else who added more value to it. So all those things have to be built through some kind of a training process. But again, with complete transparency to everyone.
You
So-
could even include like environmental aspects.
Oh
as
yeah,
well,
absolutely,
like-
absolutely,
Okay,
absolutely,
okay.
without a doubt. Sustainability and the whole triple bottom line has to be taken into consideration. So the social, economic, and environmental we'll definitely have to look into.
Okay.
Yes.
Would it be any difficulties of changing, let's say, a contract between a farmer and somebody he's selling to, say a year down the line? So you have this bit, let's say you have the actual blockchain already set up, but then later on you want to change the negotiation of the contract? Is that something you can do, or is it set in stone?
So I did mention that data in the blockchain cannot be changed, but I never said that the smart contracts cannot be altered. So smart contract is something which is coded on top, right? And when we are talking about a dynamic smart contract, right? In fact, I am planning to build in artificial intelligence into the smart contract that over a period of time, if two people have trust, okay, there would be other things that would be built into, which is, which we are actually which I'm currently trying to see. Like, suppose, somebody has to put a lockdown because you don't have trust in the beginning, but you've been transacting that person for years. Now you know that person was going to pay. You might not have to put that lockdown, and if you're not able to put that lockdown, that benefit gets translated, because then you don't have to take a loan from the bank, right? So that trust-based model, that is also something that I'm planning to build in this model, but that is going to be further down the line. Any more questions? Yes, Ricky.
What barriers are you expecting to run into, and where in the supply chain are you more likely to run into them?
The biggest barrier that I see is going to be towards the end of the supply chain. I feel that getting them would be critical to the success of this, and not having them in the supply chain would actually, but this is where, there is this whole issue of branding and being able to kind of show them the benefit. So we all know that when something is fair trade, they already have a differentiation. So that's a competitive advantage which the product has. Even if it's a commodity, they can still have differentiation, which is interesting. Now, how can we kind of convey to them that this model would give them that differentiation, or that competitive advantage is something that needs to be worked. And I think that is where the biggest challenge is going to come in from. Any more? Yes.
With the current environment right now, what do you think needs to be improved to help blockchain grow?
Current environment, yeah. So people should stop looking at Bitcoin as blockchain and start looking at blockchain as real solutions, because what has happened is that this whole Bitcoin and the explosion and all that, the price, like somebody telling you one day that it's going to be 1 million, somebody tells you the next day it's $0. Some people are going and buying Bitcoin. Actually, this whole cycle has resulted in so many people buying Bitcoin. It's not even funny, and it doesn't serve us any good. Okay, it's just a store of value. We should look at real implementations of blockchain which would change the way we do business. Bitcoin is just one implementation on a blockchain. It's just transferring value, nothing else. In fact, Bitcoin protocol does not even have smart contracts built natively on it. Ethereum is much better than Bitcoin, if you have to ask me. But Ethereum also has its own problems, at least recently, and they were not able to move into another kind of a model. But like newer platforms like EOS are much more smarter, much more stronger. They consume less energy, and they are able to execute lots of smart contracts. And I think that is where we should be looking at. Like, we just talked about a healthcare device. We should start thinking of healthcare devices rather than Bitcoin. I mean, I'm telling you honestly, it'd be a very big statement, but nobody's going to be a millionaire just by buying Bitcoin. So let's just shed that idea. I don't think that's a very good idea. I don't have a Bitcoin, any Bitcoin actually. Yes.
So we talked about, of course, a blockchain consists of multiple blocks, and more blocks are added onto it over time. But have we ever covered like when a blockchain or the addition of blocks ever stops, or if it's interrupted?
That's a good question. So, because when a blockchain becomes very famous, again, Bitcoin, you would have multiple things being requested to be added, yeah? So what happens, it's called a forking process. There could be multiple forks where, you would add, and then after a period of time, they would sync up. Now, talking about no more blocks being added has not been conceptualized as yet. However, if you download the Bitcoin right now in your machine, it's about 200 gigs, just in transaction data. That's called a full node. Okay, it's not a good idea to download a full node of that big a piece. So they are creating different kinds of modules to be able to get that blockchain network, but have a smaller version. So I'm pretty sure they'll have some kind of an archival model built in at some point. At this point of time, there's no such plan. But yes, we'll definitely get there. Actually, we should be there. 200 gigs is a lot of data. Any more questions? Thank you.